Welcome back to KSET previous year question and solution classes. Today I am going to discuss a 2014 paper. 2014 paper part 2, part B questions. In that question number 1, almost in every year they will ask from the mathematics first question, generally from the matrix, and it will be eigenvalue problems. Okay, so again in 2014 part B paper they asked about the eigenvalue of the matrix cos theta minus sin theta cos theta will be lambda is equal to e power I theta and e power minus I theta, or lambda is equal to sin theta and cos theta, or lambda is equal to minus sin theta and minus cos theta, and lambda is equal to e power theta and e power minus theta. So in these four options we have to choose the correct one. So here it's better to use a property of a matrix, property of eigenvalue. So that is, a trace of a given matrix is equal to sum of the eigenvalue, and the product of the determinant of the matrix gives a product of the eigenvalue. Okay, so the determinant gives the product of the eigenvalue. So that is, let us take trace of matrix. Trace of matrix is equal to sum of eigenvalues, and determinant of matrix is equal to product of eigenvalues. Okay, see here the trace of the matrix is cos theta plus cos theta. Trace is nothing but sum of diagonal elements of the matrix. So cos theta plus cos theta, 2 cos theta. So trace is equal to 2 cos theta, and determinant, see cos square theta minus of minus plus cos square theta plus sin square theta is the determinant, and cos square theta plus sin square theta is equal to 1. So determinant is equal to 1. In the given options we can easily guess that, see, if we add two eigenvalues it has to be a 2 cos theta. If I take sin theta and cos theta, if I add sin theta plus cos theta, the resultant value is not a 2 cos theta. So this is not a correct option. And if you take minus sin theta minus cos theta, if you add this minus sin theta or minus cos theta, it will not give say 2 cos theta, and this is not a determinant. And product sin theta into cos theta is sin theta cos theta is not is equal to 1. So this is not correct option. And if you go through this, lambda is equal to e power theta and e power minus theta. If you take a product of e power theta and e power minus theta, it gives 1, which gives the determinant. But if you add this e power theta and e power minus theta, it is e power 0, right? Sorry, e power theta plus e power minus theta. It's enough, but it is not equal to 2 cos theta. This lambda, eigenvalues lambda is not equal to trace if we add these eigenvalues. So this is not a correct option. And let's verify option number 1. If we add this e power I theta plus e power minus I theta, so e power I theta plus e power minus I theta is equal to e power I theta means cos theta plus I sin theta, and plus e power minus I theta means cos theta minus I sin theta. If we add these two eigenvalues, then plus I theta and minus I theta cancel, and cos theta plus cos theta, which is equal to 2 cos theta. Okay. So if we add two eigenvalues, the resultant is trace. So 2 cos theta, this is our trace of the matrix. And if you take a determinant, means if you multiply this e power theta and e power minus theta, so that is, if you multiply e power I theta and e power minus I theta, which is equal to 1, which gives determinant. So you should remember these two properties. It's very important. One is trace of the matrix is equal to sum of the eigenvalues, and determinant of the matrix is equal to product of the eigenvalues. Okay. So option number A is correct. Okay, and we can also solve this by characteristic root equation. So that is determinant of A minus lambda I is equal to 0. By using this formula we can also calculate this one, but here it's better to go through these properties. So we can also solve this by using A minus lambda I actual matrix eigenvalues rule. So that is A is our matrix, this one, A minus lambda I is nothing but identity matrix, right? So that is cos theta minus sin theta cos theta minus lambda into I is nothing but 1001. So which gives cos theta minus lambda into 1. So cos theta minus lambda and minus sin theta. Okay, next sin theta and cos theta minus 1. Sorry, cos theta minus lambda. Why? Because lambda into 0 is 0, minus sin theta plus 0 is nothing but minus sin theta, and sin theta minus lambda into 0 is nothing but 0, sin theta as it is, and cos theta minus 1 into lambda is lambda, so cos theta minus 1. Okay, so therefore we can write this as cos theta minus lambda minus sin theta and sin theta cos theta minus lambda, determinant is equal to 0. If solve this, we will get cos theta minus lambda whole square minus into minus plus sin theta into sin theta sin square theta. So if we solve this, if we expand this, so it looks like A minus B whole square formula. So that is cos square theta plus lambda square, okay, minus 2 lambda or 2 cos theta into lambda plus sin square theta. Okay, so therefore cos square theta plus sin square theta is nothing but 1, right? So we can write this as cos square theta plus sin square theta is equal to 1. And I am going to rearrange the equation. So finally we will get lambda square minus 2 lambda cos theta or 2 cos theta into lambda plus 1 is equal to 0. Plus 1 is equal to 0. So now we can simplify this quadratic equation. It is like a quadratic equation, ax square plus bx plus c. So it's just like an ax square plus bx plus c is equal to 0. Okay, and here a is nothing but 1 and b is nothing but minus 2 cos theta and c is look like a 1. So the formula here is better to use to simplify this is lambda is equal to minus b plus or minus root of b square minus 4ac divided by 2a, and therefore lambda is equal to minus b is nothing but minus 2 cos theta. So therefore minus into minus plus 2 cos theta and plus or minus root of b square is nothing but 4 cos square. So 4 cos square theta minus 4ac, 4 is okay, 4, a is 1 and c is 1. So 4 divided by 2 into a is 1. So which is equal to 2 cos theta plus or minus 1 root of, if you take 4 as a common as outside, it will becomes 2 root of cos square theta minus 1. So cos square theta minus 1 is nothing but minus sin square theta divided by 2. So 2 cos theta plus or minus 2 into I minus root of minus sin theta divided by 2, and lambda is equal to 2 cos theta plus or minus 2, and this is sin square theta minus sin square theta, because cos square theta minus 1 is equal to minus sin square theta. Okay, so and root of minus 1 is nothing but I, so 2I sin theta divided by 2, and these two gets cancelled, therefore remaining is lambda is equal to cos theta plus or minus I sin theta. So we can write this as cos theta plus I sin theta is nothing but e power I theta, and cos theta minus I sin theta is nothing but e power minus I theta. So these are two eigenvalues for this matrix. So these are two eigenvalues for this matrix. Okay. And this is question number 2, which is on basis on Laplace transformation. So the value of L of sine hyperbolic kt, that means Laplace transformation of sine of hyperbolic kt is, so these are the options. So s by s square minus k square, and k by s square minus k square, and s by s square plus k square, and d k divided by s square plus k square. So let's see what will be the answer. So we know that Laplace transformation of sine hyperbolic kt is equal to integration of 0 to infinity e power minus st into f of t into dt. This is Laplace transformation of f of t. So therefore Laplace transformation of sine of hyperbolic kt is equal to integration of 0 to infinity e power minus st. This f of t, in place of f of t, so we have sine hyperbolic kt. So sine hyperbolic kt into dt. So how to simplify this? Let's see. We know that since sine hyperbolic theta is equal to e power theta minus e power minus theta divided by 2, right? So therefore this equation can be written as integration 0 to infinity e power minus st, and sine hyperbolic kt can be written as e power theta is nothing but kt, so e power kt minus e power minus kt divided by 2 into dt, so which is equal to 1 by 2 into integration 0 to infinity e power kt, so e power k minus s of t minus e power, if we take minus as a common, k plus s of t into dt, and which is equal to 1 by 2 into integration 0 to infinity. If we take minus sign as a common from this height, so we will get minus of s minus k of t into dt minus integration 0 to infinity e power minus of k plus s into t dt. Okay, so which is equal to 1 by 2 into Since, so we have a formula that is integration 0 to infinity e power minus ax is equal to 1 by a. So it's look like e power minus ax dx and e power minus ax dx. So after simplifying this, we will get 1 by 2 into, so this is 1 by s minus k and minus of 1 divided by s plus k. Okay. So next, so after simplifying that, so Laplace transformation of sine of hyperbolic kt is equal to 1 by 2 into, see after simplifying that we will get s plus k minus s plus k divided by s square minus k square. So plus k plus s and minus s cancel, remaining is k plus k, 2k. So 2k divided by 2 into s square minus k square and 2 cancel, answer is k divided by s square minus k square. So option number B is correct. Okay, so this is the answer. Okay. And this is the question number 3, which is asked in the 2014 paper based on special functions. Which of the following recurrence relation is not true? So definite question from the special functions. Okay, at least 1 or 2 every year it will ask, they will come for 2 or 4 marks. So this is a given option: x into pl prime of x is equal to l pl of x plus pl minus prime of x. So this is the recurrence relation they are given, and this looks like a n pn is equal to x pn prime and minus p prime n minus 1. If you rearrange this, you will get this one. In place of n, they have written l. So this is the recurrence relation for Lagrange polynomial. So this is a standard recurrence relation for Lagrange polynomial. This is correct actually, and this is not an answer. Actually, this is correct one. This is not. This is the exact recurrence relation. And hn prime of x is equal to 2n into hn minus 1 prime of x. So this is the recurrence relation for Hermite polynomial. So this is also correct one. And 2jn prime of x is equal to jn minus 1 of x plus n j of n plus 1 of x. See, this is not a recurrence relation. There is some mistakes here, but this looks like a recurrence relation for Bessel's function. So Bessel's polynomial, and this is actual recurrence relation for Bessel's polynomial. So this is not correct, and this one, and this is ln prime of x is equal to n into ln of x minus n into ln minus 1 of x. Here x is missing, so therefore this is also not correct. So option number C and option number D are not correct, not true. In the option actually they are given only one, you have to choose one. Definitely they got grace marks for this question, because here x is missing. If it is x here, so then this is also correct, this will be correct, but here there is no x, maybe some printing error or whatever may be it. So these two are not true. So here, which of the following is not correct with regard to the normal distribution? So this is the question number 4. based on statistical mathematical part. Here, here the conditions is it is a continuous distribution. That means this normal distribution is a continuous distribution, or it is a bell-shaped curve symmetric about the mean. They are asked which one is not correct. Okay, and it curvature depends on the value of the standard deviation. Its curvature depends on the value of the mean. The mean and the mode coincide. The mean and the median do not coincide. The points of the inflection of the curve at x is equal to plus or minus sigma. So options is like this: 4 and 6 are not correct, or 2, 3, 4 and 7 are not correct, or 1, 2 and 6 are not correct, and 1, 3, 4, 5 and 7 are not correct. Actually, these are all the properties of a normal distribution. Normal distribution is nothing but a probability distributions, or we can also call it as a Gaussian distributions. In the Gaussian distributions, it is curvature is symmetric. Curvature is symmetric, and it is also bell-shaped curve. So it has a bell-shaped curve, and it's this is x and this is y. Okay. And actually it is a continuous distribution. S, the normal distributions is continuous, and it is a bell-shaped curve and symmetric about the mean. Yes, it's a bell-shaped and symmetric about the mean, and if the curvature depends on the value of the standard deviation sigma. Yes, it also depends on the sigma. If the curvature depends on the value of the mean. Yes, this is a bit of confusion. Let's see. And the mean and the mode of the mode is coincide. Yes, the mean, mode, median, so these are coincide. Yes, this is correct option. The mean and the median do not coincide. No, this is not a property of a distribution for normal distributions. And the points of inflection of the curve occurs at x is equal to plus or minus sigma. Yes, s is equal to plus or minus sigma. Actually the formula is x is equal to mu plus or minus sigma, but here mu is 0, so x is equal to plus or minus sigma. Point of intersection, point of inflection, where the curve is upping and downing, which changes its phase. Yes, but here is option we are going better to go through this 4 and 6. Actually 6 is correct. That means 6 is not a property of a normal distribution. That is, the mean and the median do not coincide. So they are given like that, but actually mean, median and mode is coincide. They are equal. Actually mean, median are equal in normal distribution, and this and also depends on the mean and standard deviation. But this is not a correct option, and this is also property of a normal distribution. Only 6 is not true, but here they are given 4 and 6. Okay, so 6 is not true. So these are all the property of a normal distribution. So this is question number 5 from Fourier series. So if f of x is equal to x for 0 to 2 and f of x is expanded in Fourier series, then the constant term in the series is, the constant term in the series we have to calculate, the constant term in the series is a0. So actually f of x in Fourier series, the f of x is nothing but a0 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx for limits minus pi to pi, and a0 is 1 by 2 pi integration minus pi to pi f of x dx, and an is 1 by pi integration minus pi to pi cos f of x into cos nx dx, and bn is equal to 1 by pi into integration minus pi to pi f of x into sin nx dx. Okay, when limit changes from minus pi to minus L to L, it's a general limit, then this a0, an, bn will changes. So that is, then a0 will changes from a0 is equal to 1 by 2l into minus L to L f of x dx, and an changes to 1 by L integration minus L to L f of x cos n pi x by L into dx, and bn changes to 1 by L into minus L to L f of x sin n pi x by L into dx. Okay, but here we have to calculate a0, and also we can write this a0 is equal to 1 by 2l into minus L to L f of x dx, right, and which is equal to a0 is equal to, you can also write this as 1 by L into 0 to L f of x dx. So here they asked only for a constant term. a0 is our constant term in the series, and put in place of L, just put the 2. So a0 is equal to 1 by 2 into integration 0 to 2 f of x is nothing but x and dx. We have to integrate this term, and after integrating this, a0 is equal to 1 by 2 into integration of x is nothing but x square by 2, limit varies from 0 to 2. So therefore a0 is equal to 2 square is 4 by 4, and which is equal to 1. So a0 is equal to 1. So 1. So option number B is correct. So this is question number 6. The question number 6 is framed from the Taylor series expansion. So we have to calculate the Taylor series expansion of sin x. So these are the given options for this. So let's see which one is correct. We know that for Taylor series, f of x is equal to f of f naught plus x into f prime naught plus x square by 2 factorial into x f double prime naught plus x cube by 3 factorial into f triple prime naught plus x power 4 by 4 factorial into f 4 naught. So here our f of x is sin x. F of x is nothing but sin x, and f of f naught is nothing but, put the value of x is equal to 0. In place of x we have to put 0. So then f naught is nothing but sin x. And next, if we differentiate this, we will get f prime of x, first time differentiation. So one time differentiation of sin x, that is cos x, and f prime naught is nothing but cos 0 is 1, and f double prime of x is equal to c, differentiation of cos is minus sin x. Okay, so then f double prime of x is equal to sin 0 is 0 and f triple prime of x is equal to minus sin x, differentiation of sin x cos x, here minus is there, so minus cos x, and f triple prime of x is the invert minus 1. So if you put these values here, so then we will get f of x, so that is sin x. So sin x is equal to f naught is, sorry, sin x is 0. Sin x is 0. So 0 plus x into f prime of f prime naught is 1. So x and x square by 2 factor to f double prime is 0 and x cube of 3. So f triple prime is minus 1. So x cube by 3 factorial, and if you solve this we will get plus x 5 by 5 factorial and so on. So therefore sin x expansion is nothing but x minus x cube by 3 factorial plus x power 5 by 5 factorial and so on, minus and so on. But this answer is not in the given option, so maybe this is also Gray's question. So this is the question number 7. The question number 7 is based on complex analysis or complex integral. The question is like this: the value of the counter integration dz by z square into z plus 3, where c denotes the unit circle mod z is equal to 1, traced in the counterclockwise direction. So this is counterclockwise direction, anti-clockwise direction. So if we consider this as an anti-clockwise direction, then only we can get the correct option. Okay, so here the question is like this: the denominator, if we equate each one to 0, okay, so z plus 3 is equal to 0 and z is equal to minus 3. Okay, and okay, and another one is z is equal to 0, and z is equal to 0 is like between the circle. If the radius of the circle is 1 and z is equal to minus 3 is out of the circle. So for this residue is no need to calculate, and the residue is integration dz divided by z square into z plus 3 is equal to 2 pi I into sum of residues. Sum of residues. So this is the answer. We have to calculate the residue for z is equal to minus 3 and z is equal to 0, but actually z is equal to minus 3 is out of the circle. No need to calculate this one, only we have to calculate for z is equal to 0. Okay, so the formula is which is equal to limit z tends to 0 1 divided by 2 minus 1 into 2 minus 1 factorial into d by dx of dz of limit z tends to 0 1 divided by z square. So z square into z minus 3. Okay, and z square cancel. Sorry, z plus 3. So which is equal to, here already mentioned the limit, so no need to write here. And 1 by 2 minus 1 is 1. 1 factorial is nothing but 1. So this is because of pole of order 2, because it has pole of order 2, and d by differentiation of d by dz of 1 divided by z plus 3. If we differentiate this, we will get minus 1 by z plus 3 whole square, which is equal to, put the value of z 0 and it becomes minus 1 by 9, and 2 pi I into residue 1 is minus 1 by 9. So answer is minus 2 pi I by 9. So option number D is correct. So this is question number 8, which is on linear vector space. So identify the correct statement for the following vectors: A is equal to 6i minus 9j and B is equal to minus 2i plus 3j. So whether these vectors, these are A and B are the two vectors, whether these two vectors are linearly independent or linearly dependent, or vectors A and B are orthogonal, or vectors A dot B are normalized. Okay, so let's see. So for that, if we calculate, so let's take this as 6i minus 9j is one vector and minus 2i plus 3j is another vector. So we can also write this as 6 minus 9, 2, 3, which if you take a determinant for these two vectors, if the determinant is equal to 0, then it is linearly dependent. If determinant is not equal to 0, then it is linearly independent. So let's see, 6 3s are 18 minus 9 2s are 12, minus 9 and minus 2. So this is minus 2. Okay, so minus into minus plus and again minus, 9 2s are 18, so which is equal to 0. So therefore which is linearly dependent. Okay, and orthogonal means, okay, no need to further options, it's a linearly dependent. Okay, let's see. In the next video, I am going to discuss a part 3 of this 2014 paper. Okay, thank you.